Hello and welcome to our presentation for Microprocessor and Microcontroller project. I am Tarunnyamoye Kundu, student ID 190217, and my fellow partners are Rahat Nabil, student ID 200227, and Sourav, student ID 200217. Title of our project is A Desktop Companion Bot with Healthy Purpose. We have named our bot Baymin 1.0. The story of the name is that it's inspired by the bot character Baymax from the movie Big Hero 6. Let's quickly start with the video clips as demonstration of the features we have implemented in our project. So firstly, Baymin welcomes the user with a friendly greeting, usually on each reboot and after a specific period of the user's absence. Let's see that.
Hello, I'm Baymin.
Well, after welcoming, Baymin notifies the user to take a break from work after a particular amount of time. The time is typically 15 to 20 minutes and ensures that the break lasts at least 5 minutes. It is a Pomodoro technique implementation. Pomodoro is a very famous technique to take breaks from work. However, if the user is attending a meeting or busy with something else, the alarm can be manually postponed. So how Baymin notifies? Let's see.
Get a break. Go get some coffee or fresh air.
Okay, so being hydrated is really important. Nowadays, people keep forgetting about having water. So our bot reminds the user every hour to drink water.
Have you drunk enough water?
Well, then Baymin celebrates by dancing along with the song after detecting a V symbol displayed by the user with his fingers every time he achieves something. By achieving, we mean the target group of users is especially coders, developers, freelancers, etc. Usually the people who sit before the PC for a very long time. Whenever they completes a task, a coder gets his code accepted, they feel free of load, right? If we celebrate the moment, they get encouraged to hold focus in a very relaxing mode. Okay, let's watch the demo. Aren't we able to bring a smile in your face? So moving on, Baymin notifies the user when it is time to go to bed, and this time can be set by the user himself.
It's time for bed. Aren't you sleepy? Go to bed.
There are several reasons for choosing this project. The first is the current demand of desktop companion bot is noticeably increasing. The concept of desktop companion bot is really cool and trendy, and it adds value to the world as we are speaking about mental and physical health awareness. Who talks about that, right? And also $767 million of current market size is held by this field. And above all, we chose this project to have fun as well. Our project is unique because the current bots are for companionship and entertainment, but we are adding health purposes. Also, people who are working on PC extremely get exhausted. They need care. So we are talking about mental health and implementing that. The bot possesses human-like interaction. And finally, as CSS students, we are doing something to help our people. By our people, we mean developers and people who sit in front of the PCs. Now let's talk about the setup of our hardware. First, we made the body and hands of the bot using boxboard and popsicle sticks. Then, attached the servo motors in appropriate positions. We connected all the control pins of servo motors to GPIO 14, 23, 16, 36 accordingly using male-to-male jumper cables. Then, we connected all the VCC and ground pins of the servos to the power adapters and connected ground of the power adapters to a ground pin of the Raspberry Pi. We placed the webcam at the front of the base and connected it to the Raspberry Pi using USB ports. We used a USB Type-C adapter as the power source of the Raspberry Pi. Now the software section will be discussed by my groupmate Nabil.
These are the scripts which are used to trigger some Python program at a startup and some programs periodically. Here main.sh, welcome.sh and break script are triggered automatically at a startup. Other two scripts are executed periodically using cron tab. These are the codes used in our project. Here realtime.py captures an image every single second and saves it. It also detects hand gesture. And here mpface.py detects whether there is a face in the image file and record the information to a file. Here we can see if the program detects a face, it writes this string true to a file, otherwise write false to that file. Using that information, this program calculates sitting time. If the sitting time of a person is more than 29, this program triggers the servo motor using GPIO pin and output an audio. Here are some programs that are triggered by the system automatically after some times. For example, here is a program water.py which reminds the user about water drink. Here we can see if the program is triggered, it will send signal to GPIO 16 and GPIO 23 and play a music water.mp3. Here are the instructions for sending signal to servo motor. There are some similar code such as welcome.py, bedtime.py, etc.
The future works may include ensuring proper light environment, to detect the user's spectacles for eye care, to detect the posture and to correct the posture whether the user is sitting straight or not, and also integrating the system with smartphone or smartwatch, and obviously any further efficiency enhancement is welcome. Thank you everyone for watching.